Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone, today we are going to discuss 10 MCQs from chapter Atoms in Physics. So welcome to Bohdi Park NEET and J Academy. You can access various study material from the app. You can download the app from the link mentioned in the description. So let's start from the first question. Now look at this first question. We have a beam of fast moving alpha particles were directed towards a thin film of gold. The parts A dash, B dash, C dash of the transmitted and reflected beams corresponding to the incident parts A, B and C. So these are the beams which are incident A, B, C, A, B, C. So suppose this is the nucleus. So as you can observe, the B is incident almost towards the nucleus. So we know that in alpha particle scattering, very few alpha particles are returned back. So very few. So the number of particles returning back is B dash. So B dash is less in number. Number of B dash is less. So B dash is minimum. And most of the alpha particles go undeviated. So as you can see, the beam C. So beam C is going very far from the nucleus. So it is almost undeviated. Or we can see the A also, it is almost undeviated. So which are going undeviated are more in number. So A will be more in number. So A dash will be more. So A dash is maximum and B dash is minimum. Next question. Now look at question number 2. The ratio of momentum of electron and alpha particle which are accelerated from rest by a potential difference of 100 volt. So the potential difference are same for both alpha particle and electron. So we know that we have momentum is equal to momentum is equal to P is equal to square root of 2m into Ke, because kinetic energy is equal to P square by 2m, and we know that the kinetic energy is equal to charge into potential difference. So we have momentum is equal to square root of 2m into QV. We have to find the ratio of electron and that of alpha particle. So that will be equal to square root of mass of electron by mass of alpha particle into charge of electron by charge of alpha particle, and the potential difference is same for both. So we have square root of me by m alpha into square root of charge on electron is E, charge on alpha particle is 2e. So you get square root of me by 2 times of m alpha. So fourth option. Now next test over. Okay. Now look at question number 3. The diagram shows the path of 4 alpha particles of the same energy being scattered by the nucleus of an atom simultaneously. Which of these are not physically possible? So we know that the alpha particle is positively charged and the nucleus is also positively charged. So gold nucleus and alpha particle, they will repel each other. So the path followed by alpha particle will be like this. Suppose this is the nucleus. So if any alpha particle is coming in this direction, so it will bend like this. If any alpha particle is coming in this direction, it will bend like this because of repulsion. So if any alpha particle is bending like this, so that is not possible because both will repel each other, they are not attracting each other. So we have to select which is not possible. So you can observe this route is not possible, so fourth is not possible. And if you observe 1 and 2, so both are possible, but maybe I think they are talking about the deviation. So for 2, the deviation is somewhat like this, and for 1, the deviation is like this. So if we consider the deviations, so first is also wrong, but it is not very clear from these diagrams. So let's consider only 4 is not physically possible. So let's consider fourth option. Next, look at question number 4. According to Bohr theory, the radius of electron in an orbit described by principal quantum number n and atomic number z is proportional to. So we know that r is proportional to n square by z. So that is a direct relation. So our answer is fourth option. How we are getting that? We can use the derivation of force, centripetal force. So mv square by r is equal to k z e square by r square. Then mv square, r cancel. So mv square into r is equal to k z e square. So now separate mvr from v. Now mvr is angular momentum, which is nh upon 2 pi. So into v is equal to kz e square. So if you observe v, it is a 2 pi k z e square by nh. This is v. Now let's consider angular momentum again. So mvr is equal to nh upon 2 pi. So we'll get r from here, nh upon 2 pi into mv. So this is nh upon 2 pi m into v, which is 2 pi k z e square by nh. So from here we can observe it is n square by z. R is proportional to n square by z. Okay, done. Now next, so look at this fifth question. We have, according to Bohr theory, the expressions for the kinetic and potential energy of electron revolving in an orbit. So we have the relation between total energy, potential energy and kinetic energy. So let's recall those relations. So we know that kinetic energy is equal to minus of total energy, and potential energy is 2 times of total energy. And potential energy, we know potential energy is equal to k q1 q2 by r. So potential energy is equal to k into q1. So that is electron, which is minus e, and charge on nucleus, which is plus ze by r. K value is 1 upon 4 pi epsilon naught. Then this is minus z is 1 for hydrogen. So minus e square by r. So this is minus e square by 4 pi epsilon naught into r. This is potential energy. And if you look at this relation, we have kinetic energy is equal to minus of total energy. Total energy is Pe by 2, potential energy by 2. So this will be minus 1 by 2 into potential energy, which is minus e square by 4 pi epsilon naught into r. So this is minus minus plus. So e square by 8 pi epsilon naught into r. So kinetic energy and potential energy So we have plus E square by 8 pi epsilon naught into R, and minus E square by 4 pi epsilon naught into R. So fourth option. Next, now look at question number 6. We have Bohr model of hydrogen atom. Potential energy is and total energy in going to higher level. So as electron moves from low level to higher level, total energy increases, because we have formula for total energy is equal to minus 13.6 electron volt into z square by n square. So suppose if you consider n is equal to 1, so total energy is equal to minus 13.6 electron volt for z is equal to 1. If you go to n is equal to 2, so total energy is minus 13.6 electron volt by 2 square, which is 4. So that will be equal to minus 3.4 electron volt. So on a number line, suppose this is 0 and this is minus 3.4, and over here it is minus 3.6. So minus 3.4 is greater than minus 13.6. Minus 3.4 is greater than minus 13.6. So this is n is equal to 2, energy is greater than n is equal to 1. And we know that potential energy is equal to 2 times of total energy. So when total energy is increasing, potential energy also increasing. So both are increasing as we move to, as the electron goes to higher orbit, both increases. Next, now look at this question number 7. We have, according to Bohr model, radius of second orbit of helium atom. So we will use the formula for radius, which is R is equal to R naught into n square by z, where R naught is equal to 0.53 angstrom for first orbit of hydrogen atom. So this is equal to 0.53 angstrom into n square. Now second orbit of helium. So this is a 2 square by z, which is for helium z is 2. So this will be 0.53 angstrom into 2. So 1.06 angstrom. Okay. Now done. Next question. Next, question number 8. Energy of electron in nth orbit of hydrogen atom is given by minus 13.6 by n square into electron volt. The amount of energy needed to transfer electron from first orbit to third. So we have the formula 13.6 electron volt into 1 by initial orbit square minus 1 by final orbit square into z square. So 13.6 electron volt into 1 by 1 square minus 1 by 3 square, and it is for hydrogen. So 1 square is 1. So 13.6 into 1 minus 1 by 9, it is 8 by 9 electron volt. So let's solve this. So this will be 1.51 into 8. So approximately 12.08. So third option done. Now next question. Now look at this question number 9. The diagram shows the energy levels for an electron in a certain atom. Which transition shown represent the emission of photon with the most energy? So again the same formula, we have delta E is equal to 13.6 electron volt into 1 by n initial square minus 1 by n final square into z square. So we'll find this value for all the transitions one by one. So for transition 1, we have to consider the emission of photon, which is possible for higher to lower. Now the arrow is represented wrongly. So if arrow is properly like this, the direction of arrow is opposite, so our answer will be 4. Otherwise our answer will be either 4 to 2 or 2 to 1. We'll calculate. For 4 to 2, delta E is proportional to 1 by 2 square minus 1 by 4 square. And for 2 to 1, delta E is proportional to 1 by 1 square minus 1 by 2 square. So this is 1 by 4 minus 1 by 16. So this is 3 by 16, and this is 1 minus 1 by 4. So 3 by 4. So this is less. This is more. So 2 to 1 is more. So if this arrow is opposite, then our answer will be 4. So let's consider this arrow is opposite. So our answer will be 4. If it is between these two, so our answer is 2 to 1. That is 3. Transition 3. Okay. Now next question number 10. Energy levels A, B, C of a certain atom corresponds to increasing values of energy. So EA less than EB less than EC. Lambda 1, lambda 2, lambda 3 are the wavelengths of radiation for C2B, B2A and C2A. So C2B lambda 1, B2A is lambda 2 and C2A is lambda 3. So we have delta E is equal to Hc by lambda. So when energy is more, lambda is less. Now energy for C2A is more than energy delta E for B2A, which is more than delta E for C2B. So wavelength for C2A is more than wavelength for B2A, which is more than a wavelength for C2B. And to find the relation, we can say delta E for C2A is equal to delta E for C2B plus delta E for B2A. So Hc by lambda C2A, which is lambda 3, is equal to Hc by Cb, which is 1 by lambda 1 Hc. Then lambda delta E for B2A, which is Hc by lambda 2. So we get the relation 1 by lambda 3 is equal to 1 by lambda 1 plus 1 by lambda 2, or lambda 3 is equal to lambda 1 lambda 2 by lambda 1 plus lambda 2. So that is the answer.